Hi folks, today we will talk about LTE architecture in detail. First, we will see what all nodes are there and what are the interfaces among these nodes. Then we will look into functionalities of each node. So, let's start. We can divide LTE network into two parts. Number 1, EPC, Evolved Packet Core. Number 2, EUTRAN, Evolved UTRAN or Evolved Universal Mobile Telecommunication System. UTRAN basically consists of two nodes, UE or mobile, and E node B or evolved node B. Interesting thing about EUTRAN in LTE is that it has got a flat architecture. It is not like 3G in which we have RNCs that are connected to node Bs and in which RNC acts as a centralized node. In EUTRAN, there is no centralized node. eNode B can do all the processing related to air interface protocols. It is an independent entity. One eNode B is connected to multiple eNode Bs through extra interface. eNode B is connected to core network by means of S1 interface. We can divide S1 interface into two parts. First part, S1 MME interface for control plane, and second part, S1U for user plane. eNode B is connected to MME or Mobility Management Entity through S1 MME interface and to SGW or Serving Gateway through S1U interface. MME is responsible for control plane signaling. Serving Gateway is responsible for user plane or actual user data flow. MME is connected to a database called as HSS or Home Subscriber Server. Home Subscriber Server component has been carried forward from UMTS and GSM, and it is a central database that contains information about all the network operator subscribers. And the information that HSS has could be maximum data rate allowed for a subscriber, keys to be used in security algorithm for a subscriber, and some more information like that. Serving Gateway is connected to PDN Gateway. PDN Gateway is the interface of the mobile network to the external world. PDN Gateway is connected to the internet and another PDN networks. Now let's talk about functionalities of eNode B. First, scheduling and dynamic allocation of resources to UEs in both uplink and downlink direction. Let's understand it. eNode B does it by scheduling and allocating the resources to UEs at every 1 millisecond TTI. So eNode B runs its scheduling algorithm after every 1 millisecond, and based on channel or radio conditions, it allocates air interface resources to the UEs that are connected to this eNode B. Second task is eNode B triggers state transition in the UE. eNode B switches UE from RRC idle to RRC connected state and vice versa. eNode B does this state transition based on the volume of the data transmitted by UE. When there is no data flow for a certain period of time, eNode B switches UE to RRC idle state. In RRC idle state, there is no RRC connection. As soon as there is data to be sent in UE, UE triggers RRC connection setup process. Third task is eNode B handles mobility of the UE in connected mode. We must know that a mobility in connected mode is governed by handovers. Handover can be triggered either by eNode B or UE. UE triggers handover when certain measurement criterion is met. All the thresholds and offset for this criterion are sent by eNode B to UE in measurement controls. If you look into signaling of RC connection, you can easily see these measurement controls. Fourth task, buffering of the data at the time of handover. At the time of handover, buffering of the data and the forwarding of the data to the target eNode B is done by source eNode B. Fifth task done by eNode B is eNode B also does transmission control and congestion control. Whenever there is a request for some new service for the UE, or technically we can say whenever there is a ERAB request for the UE from core network, eNodeB runs its congestion control algorithm to see whether new service can be admitted or not based on the current UE and eNodeB load. Let's now come to MME. First task done by MME is handling mobility in idle mode. One must note that both MME and eNodeB are involved in connected mode handovers. So MME always know which eNodeB a mobile is connected to. But if a UE moves from one cell to another in idle mode, then eNodeB and MME will not come to know about this movement. So the challenge is, if the location of a UE in idle mode is not known to the network, then how network will pay such UE if there is some call or message for this UE? So here is the solution. Every cell in LTE has been allocated a code called as tracking area code. Every cell sends this tracking area code in its cell broadcast information. Whenever a UE moves to a new cell, it decodes its broadcast information. As soon as UE comes to know that it has come to a cell which has got different tracking area code, UE triggers RRC connection and sends this new tracking area code to MME in a NAS message and releases its RRC connection. This way, MME always has latest information about the tracking area code of the cell in which a UE is present currently. This whole process is called tracking area update. There is also periodic tracking area update done by UE. Second test done by MME is maintaining UE context during idle mode of the UE. See, it's a transition from idle to connected mode or vice versa is local to EUTRAN, and it is entirely controlled by eNodeB. MME does not know anything about this state transition. Its transition is done just to save UE battery and resources on air interface. There could be multiple frequent state transitions. During all these transitions, UE context, that is, information about all the services currently used by UE is maintained by MME. Third task is NAS signaling and NAS signaling security. NAS layer of protocol is present in UE and MME. MME is responsible for NAS signaling and security of NAS messages. MME also does bearer management for the UE. If at this moment you do not understand what is bearer, don't worry. We will discuss about this topic in coming videos. Serving gateway serves as a local mobility anchor for the data bearers when the UE moves between eNodeBs. Its role is nothing but the role played by SGSN in 3G for data. When UE is in idle mode, there is no connection between UE and eNodeB. At that time, serving gateway prefers the downlink packets coming from PDN gateway. PDN gateway has got two main responsibilities. First is allocation of IP address to the mobile. When you switch on data in your mobile to connect to LTE network, an IP is allocated to your mobile. That IP is allocated by PDN gateway. Second task done by PDN gateway is filtering of downlink user IP packets into different QoS-based bearers. Let me explain it. As you know, different services or data flow in UE such as VoIP call, video streaming, browsing have different delay requirements. For example, VoIP call is very delay sensitive and browsing is not very delay sensitive. Each delay requirement can be mapped to an QoS profile, so PDN gateway filters the data coming from internet based on its delay requirement. There is one more node called as PCRF. Its full form is Policy and Charging Rule Function. Let me explain its purpose and usage. For example, service providers can use PCRF to charge subscribers based on their volume of uses of high bandwidth applications, charge extra for QoS guarantees, limit app usage while a user is roaming, or lower the bandwidth of the wireless subscribers using heavy bandwidth apps during peak usage time. So all this can be done by PCRF. So we have had overview of all the nodes. Now I would like to summarize whatever we have learned till now. Let's come to Node B and revise what all it does. Number 1, scheduling and dynamic allocation of resources to UEs in both uplink and downlink direction. Number 2, controlling mobility of the UE in connected mode. Number 3, state transition from idle to connected mode and vice versa. Number 4, admission control and congestion control. Number 5, buffering of the data during handover. Now MME. Number 1, handles mobility management in idle mode. Number 2, maintains UE context during idle mode of the UE. Number 3, responsible for NAS signaling and NAS signaling security. Number 4, does bearer management for the UE. Now serving gateway. Number 1, acts as a mobility anchor for the data bearers. Number 2, buffers the downlink data when UE is in idle mode. PDN gateway. Number 1, allocates IP address to the mobile. Number 2, filters downlink user IP packets into different QoS-based bearers. And finally PCRF, policy and charging rule function. It takes charging enforcement decisions. Whatever functionalities I have told you about these nodes, it is not a comprehensive list. There are so many other things done by these nodes, but it was just an overview, so I just listed out only important functionalities of these nodes. If you want to go into the apps, you will have to go to the text or specifications. So guys, for today's presentation, this was the only thing. In coming video, I will talk about other things such as protocol stack and the data flow and the data rate measurement and other things. So keep watching these videos and put your comments, and if you like this video, hit the like button. Thank you. Thanks a lot. Bye bye.